Sometimes ago, I didn't really know I would have a friend in you. Sometimes ago, I didn't really know you would never wanna leave me. Sometimes ago,
Okay.
I didn't really know
Okay, so today,
what to do.
the previous lessons were inverse proportion and direct proportion. So today we're going to look at what problem leading to either of the two. So I'll be giving you some questions now to look at. Your job is not to solve the question, but your job is to actually determine and tell me, is this inverse or is this direct? Okay, is that okay by you? Do you get that?
Yeah.
Is that yeah? So let me share the
Yes,
board
sir.
now so I can give you the questions. Uh, so what problems?
How is one thing?
Tell Ngozi to keep quiet. What problems?
Like my younger brother.
Okay, it is to
Keep quiet.
direct and inverse proportions. It is direct and inverse proportions. So as I said, I'll be putting up the questions. Then we're going to be seeing Eniola is about to enter the class. So Eniola, you hear me now? So
Yes,
well,
sir.
good morning. How are you?
I think it's a
Okay. So I'm going to be looking at because previous times we looked at direct and inverse proportion. So we're going to be looking at what problem that leads to direct and inverse proportion. So I'll be giving you some questions and you'll be determining from the question whether it is direct or inverse. So examples. So first example will be here. Example 1. Somebody, having. Now look at this question. Isaiah,
sir.
read the question and let me hear it.
If it takes 20 workers 8 days to harvest coffee on a plantation, how long will it take 16 workers to harvest the same plantation?
Plantation. Okay, that's for Isaiah there. So Isaiah, tell me, is this direct or inverse? And you tell me why. Okay, why?
Direct.
Why? Why? Why is it direct? Okay, Eniola, you agree this is direct?
No,
Okay, why? What is it then?
because one oh
I'm hearing underground
because
noise. Yes.
one is it's not for my sense. One is
Okay.
increasing and one is actually is going
So what do you call it? Is it direct or inverse?
inverse.
Inverse. So what is increasing and what is decreasing? Or what is decreasing and what is increasing? So that means we have 20. Isaiah, can you hear me now? Isaiah? Okay, we have 20 workers. Isaiah, can you hear me now? We have 20 workers working for 8 days to perform the test. So if I reduce the workers to 16, are they still going to use 8 days, Eniola? Eniola?
Huh?
Yes, I have 20 workers to work on a farm, on a plantation for 8 days.
Yes.
If I reduce the workers to 16, will they still use 8 days or more than 8 days or less than 8 days?
To use more than 8 days.
Why? Because the workers are now reduced. That means the days will increase. Okay, Isaiah, can you hear me now? Okay, let's try to bring out the solution to this. So, we say number of workers, workers is inversely proportional to the number of days. Then we can say worker equals to constant over day. Please make sure you're following. Then constant is going to be workers times days. And the first worker is 20 and the number of days is 8. That is 160. That means my constant is 160. Then W equals to 160 all over G. That is the relationship there. Now, if this is the relationship, then I have my workers reduced to 16. Now 16 workers equal to 160 in how many days? So the days is going to come here while the 16. So I have D equal to 160 over 16, and that gives me 10 days. So 16 here, 1. 16 here, 1. This is 10 over 1, which is 10. That is correct. Yeah, is that clear to you now?
Yes, sir.
Okay. You can't hear from Isaiah. I don't know what's the reason or it's just being distracted.
Yes, sir.
So do you get that now?
Yes, sir.
All right. So I'm going to drop the next question. Then you're going to determine whether it is inverse or direct. So this will be example 2. Example 2. Let's see what that is all about. Okay, come up here. So for example 2, this is what I have. Nine taps can fill a tank in 4 hours. How long will it take to fill the same tank if we have 12 taps with the same water flow? Now, we're comparing two things, 9 taps and the hours it takes to fill. So, is this going to be direct or inverse? Any of you?
Inverse.
Inverse, because when you increase the taps, the number of hours you're going to reduce. Yes or no? Yes or no?
Yes, sir.
Okay, so let's see what we have there, the solution. So it's going to be inverse again. Then we have taps, inversely proportional to the time taken. If capital T is for tap, small t is for time. Then we say this, then we say tap equals to constant over time. And the constant equal to tap times time. And this is going to be 9 times 4 from the first parameters given. 9 times 4 hours. And this is going to be 36. So since this is 36, my constant is now 36, then I have time equal to 36. all over t, 36 over t. And you've been asked to find time for 12 taps. So I have 12 taps equal to 36 over time. Then my time comes up, my 12 comes down. So I have time now equal to 36 to 12. And that is going to be how many hours? 3 hours. Because the time is going to be, so 36 over 12 is 3. That's 3
Of
hours.
3.
Yeah. So that is clear to you, yes or no? Is that clear to you?
Yes, sir. Yes, sir.
Okay, so I'm going to clean the first part of the board now. Then we're going to look at more examples. More examples. So now the next example is example 3. Example 3. Put that down. Don't miss out from the explanations. Next one. So example 3 is there. Yeah. It says 4 people can unload a truck full of rice in 3 hours. How long will it take 7 people? So the number of people increases, then the time taken should reduce. That is, once again, inverse. Yes or no? Yes or no? Eniola?
Yes, sir.
Okay, Isaiah, do you hear that?
Sir.
So what kind of question did I say? Is it direct or inverse? It's inverse because when you increase the number of people, the time taken to unload the truck is going to reduce. So that means the number of people is inversely proportional or inversely proportional or varies inversely as the time taken. So that means number of people equal to a constant over time taken. The constant is going to be people times time, and this is going to be the people 4 and 3 hours, so that is 12. So my constant here is going to be 12. These are the parameters from the questions. And how long will it take 7 people? So 7 people, we're looking for time again. So D equal to 12 over T. Then the time now is number of people all over. It's going to be 12 over the number of people. 12 over people, which is 7. And this is going to be, how many 7 in 12? It's 1, 5.
Remember, 5 over 7.
So that means 1 5 over 7 hours. And you can take that to minutes also. And by saying this is 60 minutes, 5 over 7 of is 60 minutes too. So 1 hour is 5 over 7 of 60 minutes. So you're gonna divide how many 7 or 5 times 60 is 300. So that is, let's work it out here. 300 7. How many 7 is in? How many 7 is in 300? That is 4. That remaining 2. 7 in 20 is 2. So remaining 6. So I'm going to say point. Then how many 7 in 20 again? That is 2, okay, 6. 60. How many 7 in 60? That is 8. That's 56. How many 7 in 40? That is 5. So 5. That's 35. 5 again. 5, 5, 5. So let's say 6 here. So this is going to be 42.8. So that means we have equal to 1 hour 42.86 minutes. And we can still check that to seconds if need be. Okay. Isaiah, I'm not hearing from you at all. Okay. So is that clear to you now, Isaiah?
Yes, sir.
Okay, very good. So let me put up another question there. Okay, probably Isaiah is trying to mute something on the ground. I can understand that. But don't hesitate to unmute yourself and ask questions when need be. Okay, next question is sample 4. Sample 4. Look at this. Example here. Here is a question here. Say, a military base had supplies for 300 soldiers for 90 days. So, after 20 days, 50 soldiers left the base. How long would the food last? Yeah, can you determine whether this is direct or inverse? Inverse. But this is kind of a tricky question because it's not straightforward. They have supplies for 300 soldiers that will last for 90 days. But now, the first thing is to know what is the number of supplies used for 1 day. When you know 1 day, you're going to remove the one that has been used for 20 days. Then you're going to now know how many days the food is going to last the remaining 50. 50 soldiers left, yes. So you're going to know how many you need to, how long the remaining 40 soldiers are going to use the remaining supplies. So let's see. Please read the question, both of you, and let me hear. Read example 4 and let me hear. Eniola, can you hear me?
A military
base, yes. Military base.
A military base had supplies for 300 soldiers for 90 days.
Okay.
After 20 days, 50 soldiers left the base.
Okay.
How long will the food last?
Okay, how long will the food last? How many soldiers are we looking for? How many soldiers? Yes, do you know? Do you know how many soldiers? How many soldiers were there? Okay, it's not even. How many soldiers were there initially?
Yes, it remains 250 soldiers.
250 soldiers, yes, that was 94. So it will remain 250 soldiers. But they've all used the supply for how many days before?
They've used it for 20 days. For
20 days. Now remain how many days to go? That's 70 days. But
70 days.
But it will last the remaining number of soldiers more than 70 days. Yes or no?
Yes.
Why? Because some soldiers.
Because they've been reduced.
Because they are reduced. So, in this case, say, let's see now. A military base has supplied for 300 soldiers, and that's supposed to be for 90 days. After 20 days, 50 soldiers left. So now we have number of soldiers to be 50. And the supplies, we have 300 soldiers being supplied for 90 days. And since we have 90 days here, 20 days gone, remaining 70 days initially. So the number of days when 50 has gone, the number of soldiers now, that is S1, the number of soldiers 2 is 250. 250 soldiers. The initial number of days is supposed to be 390, yes, when we have,
19.
yes. So this is S minus. So S1 initially was 300. So when we had 300 soldiers, the day was 90. Yes or no? Now we have 250 soldiers, and we don't know how many days it's going to last them. So if the supply for one day is supply for one day, then we can correlate this relationship. Or better still, we try to know for 90 soldiers to have, for 300 soldiers to have used the supply for 90 days. So 300 soldiers for 90 days. 90 days. Then we can compare directly and say how many, one soldier would have been for how many days? X days. So this will be this times this, So I'm going to say 300x equal to, let's say 300x 90. So x is going to be 90 over 300. But this is inverse. Just wait a minute there. Let's get something out. Get something out there. Please focus and don't write anything for now until I'm through with the explanation. Okay? On this example, okay? So let's take it 1 by 1. Now, I have the supplies for how many soldiers? 300 soldiers. 300 soldiers. So it lasts 90. They have the supplies they're going to use for 90 days. So for one soldier, we use it for 300 times 90 days if it's only one soldier, and that is going to be 2,000. Okay, 27 3 times 9, then that's 27,000 days for one soldier. So for one soldier is going to be 27. Now if one soldier is going to use it for 27,000 days, then how many days would be, and the supply for one person is gone. So 1 times 300 for 300 people, or how many days? For 20 days. That is, we have 300 times 20. Then this will be divided 300 times 20 days. 300 soldiers. That will be 27,000 divided by 300 times 20. So to know the one that remains now, this is going to cut out this. Then 3 here is 1, that's 100, and 3 here is 9. So I have 900 over 200, and this is going to be 9. This is 200.
9,000.
9,000. This. I have 27,000 initially. 27,000 over this, and this is going to be this cut. This is going to be 4.5. 4.5 supply. Okay, that is in terms of the supply. Don't put it down yet. still going to see how the thing is that 20 soldiers left. I mean, 50 soldiers left, remain 250 soldiers. Then the supplies that have been used has been for 20 days. We need to actually know the amount of supply they use for 1 day, or the correlation between 1 day, 20 days, and 90 days. But let me still clear that part. We'll come back to it so that for better understanding. Isaiah now, are you there?
Yes, sir.
Okay, very good. So let's look at this number 4 properly again. So, okay, we agree that this is going to be not direct but inverse, but this is not going to follow our regular formula. That is why it's a big head. So, they are supplied for 300 days, supply that will last 300 days for 90 days for 300 soldiers. So, if 300 soldiers can finish the supply for 90 days, 300 soldiers finishing up the supply for 90 days, then how many days will 250 soldiers use the same supply? But here now, we are not being concerned about the same supply because they have already supplied for 20 days. Is that taken?
Yes, sir.
Okay, so definitely you can go ahead and say, how many, and we don't even have an idea of what quantity of supply is. That is irrelevant for now. So 300 soldiers for 90 days, then 250 soldiers. We use the same supply in how many days? So this would have been 300x if it's direct, but this is not direct, it's inverse. Then if we correlate this would have been 300 equals to constant over days, which is 90. So the constant will be 300 times 90, and that's where we got the 27,000 from the other time. Is that taken? Is that clear?
Yes, sir.
Now that the
Yes,
constant is 27,000, you can bring it back and say, okay, the number of soldiers equals 27,000 over the number of days. Now, to know the number of days now for 20 soldiers, we say number of days equals to 27,000 divided by 250. So 0 is going to cause 0 here. Then I can go ahead and divide 2,700 by 25. 2,700 divided by 25. 7 divided by 25, and that is going to be 108. That's going to give me what?
108.
108 days for 250 soldiers. So let me clean the other part and we move on. So that is if we have the supply, the same initial supply. Are you getting? But now we don't have the same initial supply. So we need to know the fraction of supply that is going to remain. And it's going to remain just the supply for 70 days. Are you getting it? You hear that?
Yes, sir.
Now, so if 70 days supply now, because this is on the basis of 90 days supply, what it will last. So if 90 days supply will last 250 soldiers, If 90 days supply will last 250 soldiers 108. Are you with me?
Yes, sir.
If 90 days supply will last 250 soldiers 108, then how many days? How many days will 70 days supply? No. How many days will 70 days supply last the same 250 souls? Now, do you get that?
Yes, sir.
You know what we have done was that 90 days supply lasted how many soldiers now? 250 soldiers.
50.
Soldiers for how many days? 108 days. Now we have left 70 days supply because 20 days is gone. So 7 days supply will last. So this is also inverse proportion. So we can say 90 now equal to constant over 108, while our new constant will be 90 times 108. Okay, and 90 times 108 is 905,108, and that is 9,720. So my constant is now 9,720. So here now that I'm looking for this, it's going to be, this will be 70 equal to constant over x that I'm looking for, while x will now be constant over 70. So that will be 9720 divided by 70. So the number of days finally is going to be 9720 divided by 70 days. Oh no, by 70. That would be 138 days now. 138. So this question I have to take the formula twice. Okay?
Yes, sir.
Yes. Is that clear now? Isaiah?
Yes,
Yeah, Isaiah, is that clear?
Yes, sir.
Or I should go over the explanation again?
Sir.
Did I go over the explanation one more time?
Yes,
Yeah. Now look at it. A military base had supplies for 90 soldiers. I mean, for how many soldiers? 300 soldiers for 90 days. And after 20 days, they have used the supply, 50 soldiers left, remaining 250. So if 300 soldiers have the same supply for 90 days, 250 soldiers will have it for how many days? So we use our formula to get 108 days. But bear in mind that the supply have been short of 20 days. Now it's 70 days. Is that clear? Now,
Yes, sir.
so if we now say 90 soldiers use supplies of 300 days, 250 soldiers use supply of 90 days for 108 days. Then the same 250 soldiers will use supply of 70 days for how many days now? Do you understand? So from here, we were able to use the formula again to get 138 days. So is that clear now?
Yes, sir.
Okay, so is there any question before we round up?
Nope.
Okay. Isaiah, is there any question? Isaiah,
Sir.
is there any question?
No, sir.
Okay, so that is where we're going to round up the class for today. I do have a time ahead. I think I should be able to make the video about 6 minutes. Alright, so can I hear you back?
Have a good day, sir.
Alright, thank you. You too.
Sometimes,